Chemistry, Equilibrium, Problem 21. For this problem, you have this reaction. Some kind of iron mixed with some kind of cyanide will give you this product. Now, there's a solution is made that contains an initial amount of iron here and an initial amount of this cyanide here. Now, at equilibrium, this has a value, and what is asked for is to solve for K sub C, the equilibrium constant. Okay, so let's go through this. So for iron, they are showing 1.0 times 10 to the minus 3, and that's molarity. For SCN minus, they're showing 8.0 times 10 to the minus 4 molar also. And for the conclusion, remember this is initial, and this FeSCN2 plus, this is at equilibrium. So 1.7 times 10 to the minus 4 molar. So what we need to do is set up an ice table so that we can actually find what all the components are at equilibrium. So here's the ice table. I, C, E. We're going to have Fe 3 plus over here, S, Cn minus here, and Fe SCN 2 plus there. Okay, so initial for iron is given at 1.0 times 10 to the minus 3 molar. Now SCN minus is given as 8.0 times 10 to the minus 4 molar. And for FeSCN2 plus, we don't actually have anything at the beginning, so we put a 0 here. Now, the change for Fe3 plus, notice there's no coefficient, which means it's just a 1. So it's a minus. So minus 1x, which is just minus x. For SCN, over here, it's the exact same thing. It's a minus x. And for FeSCN2 plus, here, it gains just 1 also. So this one becomes positive since it's a product. So that's positive 1, x, and I guess you don't really need that one there. Now, at equilibrium, so what we do now for equilibrium, we set up this equation. So we're going to sum these two up. We're going to sum these two up. We're going to sum these two up. Now, so adding the top and the bottom, it's 1.0 times 10 to the minus 3 molar. You know what, let's get rid of the m because we're running out of space, and we'll just put a minus x here, minus x. We'll do the same thing over here, 8.0 times 10 to the minus 4 minus x, and over here 0 plus x is just x. Okay, so they're giving you the concentration for FeSCN 2 plus at equilibrium here. So they're already telling you that x is something. So you say x is whatever value they have there. So 1.7 times 10 to the minus 4 molar. Now what we're going to do now is we're going to plug this x into here and we're going to plug it in into there. Now, let's solve for this. 1.0 times 10 to the minus 3 minus 1.7 times 10 to the minus 4 gives you, if you plug it in, 0.00083 molar. Now if you do the same thing over here, just plug in the x, that will give you a value of 0.00063 molar. So this is the concentration of SEN minus, and this is the concentration of Fe3 plus, and this is the concentration of this. These are all at equilibrium. So we have the values now. So now we need to calculate for Kc. So here we say Kc equals, and this is where you make the equation from before. Go to the products first. Products are at the top, and there's a 1 for a coefficient. So it is the concentration of FeSCN 2 plus over the reactants 1 Fe 3 plus. So Fe 3 plus and 1 up there times SCN minus. This is the concentration of SCN minus to the 1 power, because that's a 1 there, which doesn't change anything. And then we just plug in these values. So for FeSCN, we use this value here. So it's 1.7 times 10 to the minus 4th molar over Fe3 plus. So we write Fe3 plus, and that's this value right there. So 0.00083 molar, and we multiply it times the concentration of that guy. And that concentration is this guy here. So it's this value goes in here. So we say 0.00063. Now this, just plug into your calculator, and you're going to get 325.10996 blah 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 blah. And we look up here. What are the significant digits? 1 and 2 for here, 1 and 2 for here, 1 and 2 for there. So it looks like there's just 2 significant digits. So significance is up to here. So we say 3.3. And that's it. 3.3 times 10, you move it over twice, so it's 2. And this is your answer, 3.3 times 10 to the 2.